Hello guys, today I want to clarify one very significant aspect about where you can see trigonometry in the theory of straight lines. And another very interesting application is about elevations. So we start from the easiest topic, elevations, and simply we define this as the angle between angle of elevation is just simply the angle between horizontal line and your side to the object. For example, here we have, let's say, we have a horizon and we have some object that we're looking for. For example, it might be a star. Okay, so we have a look from the ground and hence we've got the line of the side. It's here. So we have some angle between horizon. I want to show that. So horizon, okay, and your object. So that's your object that you keep an eye on. So you are here as observer. So this angle, what is called the angle of elevation. Okay, so what about if the object is below horizon? So for example, it might be under the water. So no problem. If your object is under, let's say, under the water surface, it might be fish. So you keep track on it, and actually the line of the side is here. So in this case, instead of elevation, you probably heard about the angle of depression. Okay, so depression here. So, okay, anyway, where's the connection with trigonometry? So the connection is pretty easy. If I put the perpendicular from the object down, you can arrange a triangle. This triangle is a right angle. So for example, you want to figure out the distance. If you know that your angle of elevation is 30 degrees, and you know that actually distance downside is, let's say, x equals 100 meters. So let's figure out the distance to the object. So distance to the object is simply hypotenuse, right? So that's why we need to use the adjacent side, which is 100 meters, and we use the hypotenuse multiplied by cosine 30. All right, so from here we can figure out distance through cosine 30 and 100. So cos 30 is square root of 3/2. That's standard value. So from where we can figure out the distance, it's simply 100 over square root of 3, and 2 actually goes up. So this is the way how the fraction works. If you divide it by the fraction, you actually multiply it by reciprocal one, right? One more time, 100 times the reciprocal fraction. That simply means that this 2 goes up. Okay, and now we can simplify that, or even calculate if you like. So 100 times 2 is 200, and divided by square root of 3 in meters. So that's the basic application of trigonometry to elevation. So every time you heard the task about elevations, so you observe the object above horizon or below, like fish, you can reserve the right angle triangle and apply trigonometry. Okay, now it's more complicated, but actually it's very interesting application to the straight lines. Okay, so let's say we have the straight line. Let's put it here. So that's y-axis, and here we've got x-axis. Okay, so we have a straight line, let's say, that goes through the following points. So 4 here, and let's say 2 here. The way back, actually, for this, I'll prefer to use positive angle and positive slope. So okay, that's our line. It goes this way. So first of all, let's try to set up an equation for this line. It goes through 4, and here is -3. All right, how to get the equation in general form? Mx plus c, that's the gradient intercept, so well, we actually can complete the general form no matter. So for example, in gradient intercept form, so let's do it. So we're talking about the gradients. So the gradient by definition is you starting from this point, so you go up by 3 units while you moving along horizon, so along x-axis by 4. So change in y, here, change in y over change in x. So that's change in y, 3 units, and change in x, 4 units. So what we're going to do, we're going to divide 3 by 4. That's our gradient. Okay, so that's why we've got 3 over 4x. And what about c? So c simply as a y-intercept, which is -3. So why it's y-intercept? Because when we have the line that crosses y-axis, what we have actually, we have x equals 0 in this point. So we can plug x equals 0 and we find out that y equals c. In our case, y is -3, so this is y-intercept, okay? That's y-intercept. All right, so we've got -3, and this is an equation of the line. All right, so we restart that. Where's the connection with trigonometry? All right, when we calculate in the gradient, we actually arrange the right angle triangle. It's right there. So that's the longest side opposed to 90 degrees angle. That's one leg, and this is another leg. Okay, so just remember, because recently we've got 3 over 4, that means that side to that side of the triangle, what we actually have. So let's have a look. We've got side 4 here, and we've got side of 3 units. So what we recently got here. Relating to this angle, we've got tangent, right? So have a look. This is the angle. Let's put the angle theta. Here is theta in degrees. We've got a tangent opposite to adjacent. So literally to say we've got the tangent of theta. That's trigonometric ratio. So and finally, where is the connection with the gradients? So that actually the gradient. All right, so tangent theta is the gradient. However, normally we like stick to the part that slope is defined from that side, but they're vertically equal, right? So that vertically opposite angles, theta and theta, they are equal. So that means we can define tangent using the gradient. So if you're given an equation, for example, of the line, let's see some example. You've got 2x minus 1. That's an equation of new line. That's line 2. Okay. How it goes? It goes through -1 from here, and it goes with their gradient 2. So it means for 1 unit here, it goes 2 units up. So that's our line. So it goes this way. Okay, so let's draw up the line. Okay, let's pretend that's your line 2. How to calculate the angle this line arranged with x-axis? So I just erase all unnecessary points. So we've got that, and we want to calculate the angle, basically of elevation of this line. So let's say alpha. How to calculate this angle? Easily. So you know the gradient, which is 2. So we can say that the gradient is 2 for that line. We want to calculate alpha, which is the slope, and in terms of degrees, right? So we know that connection for the slope and the angle is the tangent. So we can write that tangent of alpha is simply the slope. So tangent is 2. How to work out angle itself? You just go to calculator, right? press the magic button 10 minus 1, because right now you've got a number as input, number, and you want to have the output. So the output simply is alpha in degrees. Okay, so take calculators, and so let's try to figure out how much is that. So hold on, I'll be quick. Yeah, my calculator is a bit away. All right, so let's see. We've got 10 minus 1, so 10 minus 1 of 2. So make sure you have your calculator in degrees mode, otherwise you'll get the wrong way. Okay, so you've got 43 degrees. That's the way. So you can always apply trigonometry to the straight lines, and make sure you remember that tangent, your angle, is simply the slope or the gradient. So that's the connection. So tangent is always the slope. Okay, in the case if it's negative, so normally we're actually not able to calculate like angles more than 90 degrees, because by definition for a right angle triangle we need to have to be within 90, right? So all two angles are actually together within 90 degrees. But what if your line, for example, you might ask a reasonable question. What if your line, oops, sorry. Yeah, we're here. So what if your line, for some reason, it's here, and it has the negative slope. So in this case, if it has the negative slope, okay, no problem. So for example, we've got 4 units here, and let's say 2 units here. So we put the line that goes with the negative gradient. Okay, so let's remember what sort of equation this line should have. The equation of the line is simply y equals, it goes through 4 and 2. So the gradient obviously is 4 units to 2, right? So it's negative 4 over 2, which is 2x, and y-intercept is 4. So that's an equation. So in this case, we've got the gradient to be negative 2. Okay, guys. So how to work out the actual angle? So the actual angle. So here, theta, how to figure out? We can pretend that we have the line with the gradient positive 2. Yeah, can we? No problem. Because we can say that in this case, we will calculate this angle. Right? So look, if we say that the gradient is 2 for the line, so we take the absolute value for the gradient is 2, we've got the line that goes in the same manner, however, with the positive slope. So in this case, the gradient is 2 for some specific line. So in this case, we'll get this angle, so actually will be equivalent to that. And calculating alpha, or this angle alpha, we can figure out angle theta, because theta together with alpha will give us 180 degrees. So if we calculate for the positive gradient, tangent will be equal to of the angle alpha will be equal to 2, and we recently did it at 63.43 degrees. So our angle alpha is simply 63.43 degrees. So which angle we calculated? We calculated that angle, or this angle. How to figure out angle theta? So I erased the line. So we supposed to calculate angle theta. It's simply from here you can see there adjacent angles, so from where you can figure out easily the value for theta. So theta is simply 180 minus alpha, which is minus 63.43 degrees. Okay, so from there we can calculate the actual angle, which is definitely obtuse. So angle theta from there is, let me calculate, so 180 minus 63.43. And we've got 116 and 57 degrees around. That's how you can easily cope with negative gradients and how you are supposed to figure out the actual angle. Hope you enjoy, guys. That was, I think, really useful. Maybe you'll have some combined questions, combined problems, where you're supposed to define the angle itself. So feel free to use trigonometry. Hope you enjoy. Don't forget to subscribe, and peace.